The next topic is eigenvalues and eigenvectors. An eigenvector of a square matrix. So an eigenvector is defined related to a square matrix. So an eigenvector of a square matrix A is a non-zero vector V such that the product of eigenvector and square matrix must be equal to the eigenvector multiplied by a scalar. So A is a given square matrix. When I multiplied this A with the eigenvector, this eigenvector I'm representing with V. Okay, so A times V must be equal to V times lambda, where lambda is called eigenvalue. So how do you find that V eigenvector matrix? So here is an example. So A equal to 5, 2, 2, 2. It's a square 2 by 2 square matrix. Okay, that's a given matrix. Find the eigenvalues and eigenvector for the given matrix. So first thing, solve for A minus lambda I and make the determinant of A minus lambda I equal to 0. So A is given 5, 2, 2, 2 minus lambda I is nothing but 1, 0, 0, 1 times lambda, which is lambda 0, 0 lambda, right? So lambda 0, 0 lambda, it's going to be 5 minus lambda 2, 2, 2 minus lambda. Now find the determinant of this A minus lambda I. So when I find the determinant, it's 5 minus lambda times 2 minus lambda minus 2 times 2, which is 4. So I end up with 10 minus 7 lambda plus lambda square minus 4. I end up with lambda minus 6, lambda minus 1 equal to 0. So here I end up with two values, lambda equal to 6 and another lambda equal to 1. So I can call them as lambda 1 and lambda 2. Now to get the eigenvector, substitute lambda equal to 1 in A minus lambda I. So I'm substituting this lambda equal to 1 here in the A minus lambda I. So this is A minus lambda I. I'm substituting lambda equal to 1 there. So 5 minus 1, 2, 2, 2 minus 1. Now this eigenvector matrix, I'm representing this as V11, V21 equal to 0, 0. So here 4 times V11 plus 2 times V21 equal to 0. 2 times V11 plus 2 times V21 equal to 0. Okay, so I multiplied basically these two. Okay, end up with, so we should end up with the same equations. Okay, so here I have minus 2 V11 equal to V21 from the both equations. So here choose V11 value. It's up to you. You can choose any value. So when I choose V11 equal to 1, V21 equal to minus 2. So for example, if you take the A matrix, what is the A matrix here? 5, 2, 2, 2. Okay, so this is A times V equal to lambda times V. So what I'm going to do, I'm going to multiply this with V11 and V21, which is 1 and minus 2. Sorry, this value is minus 2. Okay, now when we multiply this, I will end up with 5 times 1, 5 minus 4, which is 1. 2 times 2 minus 4, which is minus 2. So here, this is A matrix, this is eigenvector, this is scalar quantity. Here I don't have anything, so I can take that lambda equal to 1. Basically this is what that lambda is. Okay, and V is the same vector, eigenvector. Okay, so this is the eigenvalue. Now what I'm going to do, I'm going to substitute lambda equal to 6. Okay, so if I substitute lambda equal to 6, 5 minus 6, 2 times 2 minus 6. So V12 times V22. I mean V12 and V22. These are the eigenvector. must be equal to 0. So when we write another equation, we will end up with the same equations. Okay, now I chose this is the equation we end up with. Choose one value, one value. So I chose v22 equal to 1, so I end up with v12 equal to 2. This is called, okay, I'm going to call this as a T matrix. We'll talk about T matrix later on, but I'm calling that as a T matrix. Okay, now if I multiply given A with the T matrix, I will not end up with a vector quantity times T matrix. It's going to be a different value, because this is not the eigenvector of A. Okay, usually the size of this eigenvector is smaller than the size of A. Okay, now I'm going to solve the next example. As I mentioned, you will get the eigenvalue lambda. So if I multiply with A times v12 and v22 equal to, you will end up with lambda times v12 and v22. Here lambda is 6. I end up with v12 is 2, v22 as 1. Okay, this is what we will end up with if I multiply A times v12 times v22. Okay, so here this is a scalar quantity, eigenvalue, this is eigenvector. Now here is the same example or similar example, a 2 by 2 matrix. So step 1, we'll find A minus lambda I. So 2 3 1 1 minus lambda 0 0 lambda, 2 minus lambda 3 1 1 minus lambda. Now determinant of A minus lambda I, make it equal to 0. So I end up with lambda square minus 3 lambda plus 2 minus 3 equal to 0. So I found the lambda values. Found the lambda values. Lambda 1 equal to 3.302 and lambda 2 equal to minus 0.302. So substitute lambda 1 in A minus lambda I. So 2 minus 3.302, 3, 1, 1 minus 3.302, v11, v21. Okay, sorry, my writing is not good. v11, v21. Make it equal to 0. So based on this, I'm going to end up with, I end up with, these two equations are same. Okay, definitely will end up with the same equation. If you're ending up with a different equation, for sure that eigenvector does not exist for that matrix. Okay, so here I chose v21 equal to 1, v11, I end up with 2.302. Okay, do I need to choose only one? No, it's up to you. You can choose any number. Okay, you can choose 2, 10, 100, 1000, whatever it is, but I always go with the smallest one, make it easier. Same way, I substituted lambda 2 equal to another value minus 0.302 in A minus lambda I. I end up with v22 equal to 1 and v12 equal to 1.302. So my T matrix here, my T matrix T equal to 2.302 1, 1.302 1. That is my transpose matrix. Now here is another example. Here it's a 3 by 3 matrix. Given matrix is 3 by 3 matrix. A equal to 0 1 0 3 0 2 minus 12 minus 7 minus 6. Now A minus lambda I found that value. So 0 minus lambda 1 0 3 minus lambda 2 minus 12 minus 7 minus 6 minus lambda. Okay, so I ended up with a third order polynomial equation, characteristic polynomial equation, lambda cube plus 6 lambda square plus 11 lambda plus 6 equal to 0. So here it's a third order system, third order polynomial equation. How do you solve it? You can do it by trial and error method, or you can use a calculator. So here I used calculator to find these values. In the exam I might provide the link for the calculator, or I might give you the at least one pole. So if you know one pole, finding remaining two poles is not too difficult. Now I substituted lambda 1 equal to minus 1, so that equal to 1 1 0 3 1 2 minus 12 minus 7 minus 5. Okay, so same thing. This is the eigenvector. Okay, this is the eigenvector. Okay, make it equal to 0. So I have three equations. So based on these three, I chose one value. Okay, so this is I chose this. As I mentioned, I always choose one, but it's up to you. You can choose 2 or 10. Still, we will end up with the same equation. Okay, and if I chose v11 equal to 1, v21 equal to minus 1, I substituted these values in second equation. I end up with v31 equal to minus 1. If you substitute these values in the third equation, it must valid. So I have minus 12 minus 7 times minus 1, so plus 7, minus 5 times minus 1 plus 5, which equal to 0. So these values are right. So I found v11, v21, v31. Now I substituted lambda 2 equal to minus 2. So when I substitute that value, this is what a minus lambda I. Now I found v12, v22, v32. So from the first equation, I chose v12 equal to 1, so I end up with v22 equal to minus 2. I substituted these two values. I substituted these values in the second equation, third equation. They both gave me the same value, v32 equal to 1 by 2. Substitute lambda 3 equal to minus 3. So I end up with a minus, this is a minus lambda I. Now I found v13, v23, v33. So in the first equation, I chose v13. I chose this value. I found v23. Then I substituted these two values in the second and third equation. They both gave me the same value of v33 equal to 3. Now this is my T matrix. Okay, I'll stop this video here. With this, I'm done with I already posted a couple of other videos on the eigenvalues and eigenvector. So with this, you should know how to find this T matrix. This T matrix is useful to find something else in the future. I will explain that there. Thank you.